here. All right, so overcome protection devices, like I said, overcome protection devices, Derek, my friend, will protect you from overload and short circuit and ground faults. There are two major types, one fuses, one circuit breakers. You guys have seen this before. We'll talk about list and identify the types, the classes of the fuses. There are different type of fuse classes that you can use, from current limiting fuses into dual element time delay fuses, into fast acting fuses and what's not, as well as circuit breakers. Operation of fuses, circuit breakers, type of fuses, circuit breakers. So a lot of information, guys, that we're going to throw at you. Again, you can capture as much of this information as you can, but you be aware, every circuit that you guys have done with me in Revit, as well as in the schedules, you have to have an overcome protection device for it. Understanding of switch sizes, rating. Every time you have Adam, every time you have a fuse, you have to have a disconnect with it for the most part. So every time you put a fuse, we have a disconnect so we can isolate that fuse. So we'll talk about the rating of the disconnects. Next week, guys, I have just activated the software for you. Yeah, yesterday your software is active. So we're going to be talking about short circuits. So with this comes a very important concept, which is interrupting rating. There's something called the interrupting rating. Let me go grab my pointer here. There you go. So we have my interrupting rating right in here. We have the short circuit current. We have the I squared T, the energy, the I peak, the magnetic force, current limitation. All these concepts are related to interrupting a short circuit. So what does that mean? You take phase A, phase B, phase C, time together, flip the switch, what do you get? Short circuit. That short circuit will contribute to something called I squared, the current squared multiplied by the time. That's the amount of energy that you're going to cook your equipment. Major part, guys. Next week, major part for arc flash. IP, the peak of the signal, guys, when you have a short circuit, that will contribute to the magnetic force is going to be imposed on your system. So we'll talk about national active code, guys. Installation, requirement for installation of an EC code book, the requirement of installation of the overcome protection device based on an EC code book, time, current characteristics. If you guys understand this one now, Karen, next project and next week, you'll have a very easy way going through the time current characteristic curves that we use for fuses and circuit breakers. With it, there's a peak lit through. That's how much energy a fuse or a circuit breaker can allow to go through before it opens. Before it opens. Excuse me. So if you guys go to Article 240, Article 240 will tell you equipments and feeders, branch circuits, and service interest conductor have to be protected based on their ampacity. So that's very simple. If you have a panel, you have to protect the panel with an overcome protection device. If you have a conductor, you have to protect that conductor based on its own ampacity. When we protect them, gentlemen, we use either a fuse or a circuit breaker. A lot of us in the engineering community use a lot of fuses, circuit breakers, and fuses have a lot of application too when it comes to protecting equipment. The whole idea, guys, of having a circuit breaker or a fuse is to protect the conductor from excessive temperature because of short circuit or overload. If you don't care, Karen, about your conductor smoking inside the pipes, if you have a ground fault or if you have a short circuit, then circuit breaker doesn't mean anything. Obviously, we do. So you have to install your overcome protection device, use a circuit breaker to protect these conductor based on their ampacity. Okay, there's UL and NEMA has standards for the fuses and the circuit breakers, guys. As you grow into this industry, you can see different type of classification for the fuses and different type of classification and types and rating. And testing criteria for breakers, as well as for circuit breakers, as well as fuses. So a couple of these, one of the good things, guys, about UL listing and so forth, you have circuit breakers that are rated for 600 volts, circuit breakers that are rated for 5,000 volt, circuit breakers that are rated for 15,000 volt, circuit breakers that are rated for maximum 250 volt. Same thing for the switches and the fuses. The switches and the fuses that goes with them. They rate most of the stuff they're going to be dealing with either rated for 250 or rated for 600. If it's 600, guys, you're looking at 480 system and 600 volt system, 3-phase or single phase. This one, you're looking at 208 or 240, single phase or 3-phase, where you can apply these switches. Any comments, guys, about the voltage rating of the switches? Comments about the voltage rating of switches? Either if your system is 208, your switch can be rated for 250, right? Slightly higher than what your voltage is. All the terminals for the switches, guys, are rated for cover unless they say otherwise. And when you land your conductors and the terminals, the lugs, like everything else, guys, you go to the 40 to the 60-degree column if your conductor are between these two values. If your conductor is larger, is 1 aught or larger, then you go to the 75-degree. And we went through this, guys, when we talked about using the ambient of 310.15b16. We said if your conductor atom is 1 aught or larger, you default to 75-degree column when you size, because the lugs will be rated for 75. If your conductor is number 1 or smaller, you default to 60-degree column, unless you know otherwise. They also have a ground, the switches that go with the circuit breakers. These are basically the switches that right here that we go with the fuses, that combo. These also, guys, can have a ground fault protection with them, where you can sense they have a ground fault and you trip the circuit breaker based on a ground fault. Ground fault protection atom, all what it does, it just looks at the ground fault. It doesn't care about the phase-to-phase or 3-phase. You have a ground fault condition, it trips. You don't have a ground fault condition, it doesn't care. So, not this project, Karen. Next project, guys, you guys will be installing a ground fault protection with visual. Hopefully, you guys will come when we start using visual. Disconnect and switches, guys. It says the occupants have to have access to the overcome protection device. That's an NEC code book requirement. So it talks also about mounting the switches. When you mount the switch or the circuit breaker, they have to be readily accessible. Occupants have to have access to them. They can't mount them over steps. You can't put them in a closed closets, in dwellings. You can't put them in a bathroom, and a bunch of other locations where you cannot put these circuit breakers. So these are fuse circuit breakers. Fuses and circuit breaker, guys, have ratings. The most important one, guys, is the voltage. So here's the 600 volt rated fuse or circuit breakers. They also have continuous amps. That can go from 15 amp all the way to 6,000 amps. 6,000 amps. These are amp rating. Voltage rating, like I said, you have 250 volt, 600, you have 5K kilovolt, you have 15 kVA, and then you go, I think, 25 kVA and higher than that, 35 kVA and what's not. So these are the voltages. What this means, Adam, if your system is 480, you can't use a circuit breaker or fuse rated for 250, right? If your system is a 300 amp, you can't use a fuse or a circuit breaker 400 amp to protect it. So the voltage of the system have to be equal or less to the voltage of the fuse, and the current of the system have to be equal or less to the current of the circuit breaker or the fuse. So protection of conductors. There's the 800 amp rule, guys. We talked about the 800 amp. Up to 800 amps, your conductors can be slightly less ampacity than your circuit breakers. Higher than 800 amps, you must start matching your conductors to the overcome protection device. I have an example I'll show you here in a second. There is a term that we talked about, guys, called interrupting rating. That's the highest amount of current that a fuse or a circuit breaker can interrupt under standard test conditions. So, Adam, a second ago, I gave you guys this number that says 35 kilo amp, right? We just wrote it. This means the circuit breaker in that panel is rated for 35, meaning you can interrupt up to 35. If you put 45 in it, you will explode that baby completely. It will explode. So that's the interrupting. Let me share a couple of slides about that one. This one, guys, confuses the people all the time. When you have, look at this one. If you have a 500 kcm conductor, you can land on it 400 amp circuit breaker because of that ceiling of 800 amp or less. Look at the load at 380. If you have an 800 amp, the same thing, two of these will get you this amount of amps, and that's okay. Now, if you go higher than 800 amp, these are the 800 amp limit. If you go higher than 800 amp, guys, then your conductors must match the overcurrent protection device, which means you cannot, this is a violation, like we said, you cannot use it. You cannot use these. You have to use probably 3 conductors, number 600 or something like this, kcm, because your conductor ampacity must match the overcurrent protection device. Any comments, guys? Any questions about this? Any comments? Any questions about matching the conductor ampacity to the overcurrent protection device if you go higher than 600 amp? I mean 800 amp. And Karen, you will be doing this in the spring. So when it comes to the spring, guys, and you size your 4000 amp switch gear, that's exactly what you're going to do. You're going to go divide it by 10 and divide the 4000 by 10 and find how many sets you can install. Short circuit ratings. When it comes to the short circuit ratings, guys, and interrupting ratings for motors, what they do is they have, like for example, they put number 12. Here's number 12 here sitting. Can you guys see they take phase A and phase B time together? That's your short circuit, and that's how they come up with rating for interrupting rating for circuit breakers. Interrupting rating for circuit breakers. So if the circuit breaker can handle that one, we're good to go. If it can't, then so look at you take the 4 feet from here from the service, put these conductors in, tie them together here. If the circuit breaker can handle this one, you're giving you a 10 inches here. And anyway, so that's how they rate the circuit breakers when you say 10,000 amp interrupting rating. UL does that all the time. Okay, so that's any comments, guys? Any questions? Comments, questions? It sounds like Friday today. Any comments, guys? Any questions about the 800? Any comments? Any questions? I can't emphasize, Karen. There's a lot of people in the industry would love to make you a drafter. What we guys emphasize here is you're going to be more than drafter. Now, if you want to, that's going to be up to you guys to be a drafter or more than drafter, which is a design part. Short circuit current ratings. There's interrupting rating, Karen and Derek, my friend, and short circuit rating. Interrupting, you have a fuse, how much this fuse can handle before it explodes. That's interrupting. Withstand rating, or short circuit withstand rating, there's a conductor. How much this conductor can handle short circuit before it burns? Because conductors don't interrupt the current. So withstand fault current equal to or less than the short circuit current. Speed of response. When you have a circuit breaker, guys, or a fuse, the higher the short circuit, the faster the fuse will trip, and you're going to see this one in less than a second here. So same thing for fuses or circuit breakers. So it will open faster if the short circuit goes higher. It will open faster if your short circuit goes higher. The fuses, my friend, when it comes to the fuses, and I'll show you a couple of things here. Dual element time delay fuse, very common. That's what you use with overcurrent protection device. There are dual element time delay fuses, and there is non-time delay fuses, and there is current limiting fuses. When you use dual element time delay fuses, it will give you a backup overload. Time delay in a low voltage range will provide a backup overload for your and you delay it because you don't want it to trip. So when your motor starts, it doesn't have harmless overloads, can be handled. It wouldn't trip. It will provide a backup overload if it says appropriately for your motors. So that's an application. Typically, Adam, if you have an air handling unit, chillers or what's not, motors, they like to put a dual element time delay fuses on them. So it allows the motor to start, and if there is a short circuit or stall, it will trip. Like I said, your overload relay fails to operate, you have a backup overload protection. Backup overload protection. Okay, so that's type of dual element time delay fuses, guys, will also allow you to operate your motors without tripping on the start. It will handle the inrush current, which is every time you start the motor, there was 6 times larger current comes through the system to start the motor. Dual element time delay fuse will handle it better than non-time delay fuses, so they won't trip. They wouldn't trip when you start your motors. If you guys have done this with me, and you will continue to do it also next semester, when you have a dual element time delay fuse and you want to size it to protect a motor, you use 175%. What does that mean? Here's my fuse right here. Here's my motor. My motor is 100 amp, say 100 amp motor. Then this will be 175 amp fuse, no more than 175 amp fuse. If it was a non-time delay fuse, then you do 300. And the dual time in the overload condition, guys, it can handle up to 5 times for 10 seconds. So it will provide you, it's like almost a heater. It'll provide you a backup overload protection, Fast acting fuses, guys. Fast acting fuses, these are fast. They with current limiting, they trip fast. So when you size them in motors, you have to oversize them a little bit. Extremely fast, both in the low voltage, the overload condition, as well as the short circuit. Has lowest energy lit through, meaning when you put them in an equipment, it will not, after the short circuit condition is there, cleared, your equipment will survive, will live to fight another day, like we always say. Better protection for feeders, sub-feeders, circuit breakers, if you have to protect the circuit breaker, like bigger circuit breakers, ducts, switch gears, and so forth. Fast acting fuses. You don't put them in motors typically. You put dual element time delay fuse motors on because of the inrush. On cartridge fuses, guys, the following things by the NEC code book must be on it. And I know you have to be marked on the equipment. You have to have the amp, say 100 amp. The voltage, say 600 volt circuit breaker. Interrupting rating, say 10,000 amp. Current limiting, if it's a current limiting, it will tell you it's a current limiting. And the manufacturer, say Boston or any of these manufacturer the fuses. These are the things that are required by the NEC code book to be on a fuse. Very similar to them also circuit breaker. Interrupting rating, if other than 10. If it doesn't have an interrupting rating, this means it can handle up to 10. This is talking about the plug fuses, guys. You can plug them into a socket. These are, you can add them as a couple of characteristics for them. For example, they have standard link time. If fuses have a time delay, you can get a time delay. Does not have a time delay on them. This one, loaded link type will give you a time delay fuses. So dual element time delay, another component. And how it works and what's not. So these are the plug-in. You guys familiar with that one? They put them in the garage, like the garage door, and what's not. They come in different types and sizes. When you test fuses, or the first thing you need to do, guys, because of OSHA, you have to turn the power off. So that's why we typically have a disconnect, where you disconnect the fuses, you remove them safely. I know you're not electricians, but if you can't even touch these if you're not electrician by law. You be very careful, guys. You walk into a place, you grab your voltmeter, you start doing measurement, it blows in your face. Your insurance might not cover you because you're there as a designer. You're not an electrician. But this is a few things where you can do when you're checking a fuse. If you want to check the fuse is open, disconnect. Open the disconnect, remove the fuse, ring that fuse. If it rings, low impedance, means it's okay. If it's very high impedance, this means it's burned. If you want to check the fuse hot,
You go put the voltage right across the line side and the load side of the fuse. If the voltage is close to zero, then the fuse is good. If there's a voltage across them, then then this fuse is burned. So this is a few things about testing the fuses and what's not. Any comments, guys? Any questions? Any comments? Any questions? I'll show you a few pictures too. There's something called cable limiters. Um, Cable limiters, guys, I'll show you a very good picture of them. They are typically used when you have parallel conductors. And Derek, what they do, these, if you have 5 conductors in parallel, if one of them shorted, do you really want to lose the whole 5? You would hope not. So they have a current limiter that opens and isolates the faulted conductor. So great design. Then the load will be divided between the rest of the cables. So that's the available to, you can do it cable to cable, cable to busway, aluminum or copper. They call them cable limiters. Here's what they do, Karen. I have 3 sets of 500 here. Adam decided to go use his saw, and he went and he cut right through this pipe. Could that happen? Somebody's digging and they cut right through one pipe. Now remember, there are 3 sets of conductors in parallel and coming to two loads like this. Now, do you guys want these circuit breakers to trip right here? Or do you want these circuit limiters to open and isolate this feeder? So that's what they do. If they call them current limiters. They look at the short circuit only. If one of these feeders is to short circuit in it, they open, isolate that feeder, and these will continue to operate. These guys will continue to operate properly. Great application when it comes to paralleling. Grounded B phase. I know this. We're doing commercial. We're not doing industrial, but sometimes you guys have a D, a delta. I have a picture. Here's a delta. Corner grounded delta. We talk about grounding, guys. In the US, what we do, most of the system that we use is grounded system for the most part. We also can run ungrounded system, but the ungrounded system has a problem with voltage transient and what's not. So what they do is they come sometimes and they ground one phase, typically phase B. When you ground the phase B, look how it gets, and you bring it right directly into here. So long story short, you cannot put a fuse in a grounded conductor. That's violation of the code. So they have this neutral bar that they put there, which takes the place of a fuse. So that's what they do when it comes to the corner grounded delta. You're not allowed to put a fuse there, so you have to put the neutral copper bar instead of the fuse in a grounded phase delta. There you go. They call it solid neutral. That's what the term I was looking. They call it solid neutral. So Karen, you have a fuse disconnect here with 2 fuses and a piece of copper that looks like a fuse is stuck in the location where the fuse is supposed to be. Because by code, you cannot open a grounded conductor unless you simultaneously open the other ungrounded conductor with it. If you're using the fuses as an overload, guys, that's an exception. If you're using the fuses as an overload, then you can put a fuse. Only if the fuses are using as a short circuit, ground fault, and overload protection, and you have not installed a separate overload protection for the system. They allow you to do that. Solid neutral, copper aluminum, based on the voltage and the interrupting rating that you need. Time current characteristic curves and B click-through curves. These are all the curves that we use, guys. There's something called time current characteristic curves. We're going to be doing this one next week, guys. You're going to be looking at these. Every circuit breaker has that time current characteristic curves, meaning the faster the short circuit or the ground fault, or the larger the short circuit or ground fault, the faster the fuse or the circuit breaker will trip. And peak lit through charts, will allow you certain fuses, guys, to allow certain amount of energy to go through up in the short circuit condition. Who cares? Your equipment will survive to live another day. Good indication of current limiting effects. So that if you have a bolted short circuit. Now, a few things about circuit breakers, and I will show you guys. I will go to the curves in a second. I have a couple of curves I want to show you. Circuit breaker, definition of a circuit breaker, guys, a device that can manually be turned on and off and automatically if you have a short circuit or ground fault. That's it. You're looking at it right there. If you can go use it as a switch, turn it on and off manually, or if you have a short circuit or a ground fault condition or overload condition, they will automatically open. There are the types that we're using for this project, guys, is molded case circuit breaker. There are power type circuit breaker and insulated type. These will be using them. Typically, they are applicable for something like 1,000 amp. Make more sense at 1,000 amp level or higher. 1,000 amp level or higher. For certain application, power circuit breakers, data centers, hospitals, and what's not. The cheapest one will be molded circuit breakers. You're looking at them right there in that panel. They're all molded together. Power circuit breakers, I'm going to leave this one, guys, until we have one right there inside. But next project, we will be using power circuit breakers. Karen, these power circuit breakers, like a foot by a foot by a foot, they are really big devices, and they have a lot of gadgets on them. Here's your molded case circuit breaker. I believe they can make them up to 1,200 amps, if I remember right. 1,200 amps, you should be able to get them. After that, you can make the power circuit breakers and what's not. Single phase, 3-phase, or 2-phase. The most common and the cheapest component, guys, is called circuit breakers is called thermomagnetic. Thermomagnetic has a thermal component that looks at overload, and magnetic component that looks at short circuit, and also ground fault. That's it, 2 components. One of them is in charge of short circuit, the ground fault. The other one is in charge of thermal. So that's, and there's also, they need a time to unlatch and interrupt these circuit breakers. The mechanism of working for them, bimetallic element that on a continuous overload moves until it unlatches an inner tripping mechanism and open the circuit breakers. So that's ambient compensation. If you have a thermomagnetic circuit breaker, guys, they are temperature sensitive machines. So you have to compensate for if your circuit breaker is in a very hot location. You have to take this into consideration when you set your circuit breaker, because they will give you nuisance tripping. If your circuit breaker is in a very cold location like Minnesota, or was it 6 this morning, you put circuit breaker out there, you think it's going to wake up if you have an overload condition. That guy's going to be so cold. It takes a lot of overload condition to get that one to wake up. So you might have to take this into consideration. Or you will have to take this into consideration. The ambient temperature effect on circuit breakers is major. Extremely hot or extremely cold, consult the manufacturer literatures. Extremely hot or extremely cold, guys. Again, extremely hot and extremely cold. You have to readjust your circuit breakers. Why? Because circuit breakers can open or not open. Open when they're not supposed to, and not open when they're supposed to because of the temperature. Okay. Common misapplication. When you guys, we'll do this one next time. If this is my panel, here's my panel. If the short circuit, guys, here is at 25, or let's just say 35.9 thousand amp, the circuit breaker interrupting rating cannot be at 22.5 thousand amp. So if the short circuit is higher than the interrupting rating, the circuit breaker will explode. So how do you solve this problem? You can make this one say 45,000 amp interrupting rating. So you can't do that. That's your misalignment. You're going to be doing this one, guys, with me next time too. There's something called series rated. When we invited um, Todd Christensen, I don't know if you guys remember when he was here and he talked about series rated equipment. Series rated equipment, a cheap way of doing it, typically panels, receptacle panels, lighting panels, where you can have the circuit breaker rated. Um, um, Two circuit breakers rated. One of them is rated for higher interrupting rating. The second one is rated for lower interrupting rating. They work together to handle the circuit breaker condition. So it's a great application for lighting and receptacle panels. What's wrong with them? Why do we care about them? Because they cost less and they're economical way application. You cannot install anything not exceeding the interrupting rating of the overcurrent protection device. You can't install a lot of motors, guys, when the series is rated. When it's series rated, here's what a series rated is. This guy is rated for 22. This guy is rated for 10. The interrupting rating right here, say, is 15.35 thousand amp short circuit. And this, under this condition, this guy will not try to interrupt it, and the guy that will interrupt is this, the main circuit breaker. You will lose selectivity, but knowing that this condition will happen probably only 5% of the time, so you can live with it. The 5% of the time. So up to 95% or 90% of the time, you're protected. Any comments, guys? Any questions? Any comments? Any questions? Comments, questions? So I can't emphasize, guys, this chapter taking you to the next level, to the short circuit and coordination. And I know a little bit harder, but it is what it is. So interrupting, costly. So we could talk about that one. Series rated for motors. When you have motors, and in a series rated panel, when you have your motor, guys, you have to make sure that you don't exceed 1% load motor between the in the panel that's series rated. So sum of connected motor full load current shall not exceed 1% of the interrupting rating of the lower circuit breaker. Otherwise, you cannot do series rating for them. You cannot do series rating. And I know this is series rating is an engineering, guys, so probably we'll deal with that. Current limiting. Current limiting, guys, there's a concept called I squared T. You're going to hear this one all the time, guys, I squared T. What they do, fuses typically, is when they interrupt within half a cycle, guys, they will limit the energy that the equipment will be encountering. Who cares? After a short circuit condition, your equipment will not burn. Is that a good idea? I mean, so current limiting breakers or fuses will limit the I squared T, which is the energy that the fault will generate by interrupting within half a cycle the fault, and that in turn, guys, will protect your equipment. Okay, so we stand circuit breakers. Any comments, guys, about the current limiting? Why do you're going to hear this one, Derek, when you work in Atom in the industry about current limiting fuses. The major part for them, they limit the I squared T, the I squared T. Cost consideration, again, selectivity. When you have an overcurrent protection device, guys, a lot of engineers like circuit breakers. If you have machines and you want to protect them properly, most likely you will have another set of fuses right by the machine to limit the energy, the I squared T and IP. So there's a lot of consideration in terms of cost and application and selectivity in selecting an overcurrent protection device. When you're using motor circuits, when you're putting them in motors, if you're using circuit breakers, the multiplier can be 250. So a 100 amp motor will have a 250 amp circuit breakers maximum. Again, you can go lower than that. If you're using instantaneous strip circuit breakers, which is no overload in it, you can go as high as this, or if it's energy efficient, as high as this number. These two numbers. Under engineering evaluation, you can even go higher than that, believe it or not.
if it says it keeps dripping, if the motor keeps dripping, guys, engineering evaluation, you can take the 800 for the instantaneous, make it this value, and the 1100, make it this value.
So, and I'll leave this one to the engineering evaluation. Okay, if you have hackers, guys, if you have equipment, HVAC equipment like compressor, condensing unit, and what's not, the manufacturer of the equipment will specify the type of the overcome protection device that work with their equipment based on the characteristics, operating characteristics of this equipment. And they will specify, Adam, for you either, they always tell you the maximum overcome protection device, either a fuse or a circuit breaker, maximum fuse, or a hacker, heating, air conditioning rated circuit breakers. So we always, for HVAC equipment, Article 440, we always take what the manufacturers tell you on the nameplate. What you guys did with me on the chiller, and if you haven't done that, you haven't done it yet. So on the chiller itself, the condensing unit, you're going to go, I will tell you, I think it's 110 amp that you need for this chiller, a fuse. So you have to put a fuse. So that's what I want to show you guys. I have a couple of pictures here. Pictures may be more interesting than that.
So the most important things, guys, here's a couple of fuses and fuse holders, the fuse holders and fuse. So you have, look at the fuses and the fuse holder that can go through them, guys, the 250 fuse and 30 amp fuses and 60 amp fuses. So you can't put a 60 amp fuse in a 30 amp fuse holder. You can't put, can you guys see that? You can't put this one here because the voltage is mismatched, and you can't put this one here because the current is mismatched. Can you guys see that? So that's what the code tells you. You can't put a fuse lower voltage in a higher voltage holder, or a fuse higher amp in a fuse lower amp holder. Current limited fuses, Karen, limit the energy. So the smarter than you and I decided that they have a rejection pin right here. So when they put them, that rejection pin, that will, class R, right in here, will not accept non-current limited fuses. Can you guys see that? The difference between this? So this cannot fit right in here. This will. Because the way they designed it. They just want to make it dump-proof, guys. Physically, you can't install a non-current limited fuses in a place where you need a current limited fuses. Otherwise, you'll mismatch the equipment. We talked, guys, about the cable limiters, and we said this is great application for paralleling conductors, so they can isolate one set upon the short circuit condition. Utilities also use them, guys. There's multiple apartments here. Fed from a transformer. If something to happen to this feeder, the current limiter that's going to this set will open and leaving the other two apartments up and running. Solid neutral.
We talked about the solid neutral, Adam. Here's what, if you have a corner grounded delta, can you guys see that right here, corner ground delta? You have to have a solid neutral here because you can't put a fuse in a grounded conductor. The exception for this one, guys, right here, if the fuse is used as an overload. If the fuse is used as the only overload. So that's an exception. Here's your neutral bus. Okay. The last thing, guys, here's the time current characteristics curves, Karen. So here's all the fuses that you can do. Here's, for example, here's my 100 amp. At 100 amp, this fuse will trip close to what? Let's see, 20. This is 10, 15, 20, 25, like 28. 28 seconds, it will take this fuse to trip. And this happened to be a 30 amp fuse. So can you guys see a 30 amp fuse? It will take a 30 amp fuse. A 30 amp fuse, 29 seconds to trip if you have a ground fault or an overload condition of 100 amp. That would be probably overload condition. Any comments, guys, about the current time current characteristic curve? Next week, Karen, you guys will be using a software that can generate these. So please, please pay attention to this chapter because next week, like I said, you will be using generating these drawings. Very simple. On this side, guys, you have the currents. The more to the right you go, the higher the current. On this side, you have the time. The more you go up, the higher up, the more time it takes to trip these circuit breakers. Okay, here's a couple of also multiple fuses, guys, and current characteristic curve for them. Current limiting characteristics. If you have a current limiting fuse, guys, and I teach this one, Derek, to the master electrician journeymen, and they're still confused with it. So if you're not confused with it, you're a genius. Because I teach it for masters and journeymen, and they still don't get it. It's really more on the engineering side. So for current limit fuses, guys, they take an interrupting rating of 40,000 amp, and they put the current limiting fuses, looks like 100 over here, and it kicks it back to this curve, and that will make it down to 46. You know what that means? A 40,000 amp short circuit will be seen downstream as 4600. Who cares? Now your VFDs and soft starts and PLC is not going to burn. Major concept. So that's the heat. Now you go back to this side, the peak, that's the cooking. If you continue, guys, here, that's the amount that you're going to get the magnetic force, I peak they call it. This will knock it down to this value. So this value is knocked down to this value from 92,000 to 10,000, and this value is knocked down from here to here. Who cares? Your equipment, when you have a short circuit condition, is not going to be baked and shaked as much. Who cares? Your VFD and soft start and PLC will survive. They're not going to burn. So that's the lit through characteristics and the current limiting characteristics of fuses, typically fuses. That's a major concept. So this is available short circuit current and interrupting short circuit current limiting fuses. They can limit the current up to current limitation, guys. Here's a 100 amp fuse current limiting rated to 2000, so we'll limit the current that these will be exposed to, so it will not be burned. More of the low peak ones. Ground fault protection, gentlemen, and again, we will be talking about the coordination as we move on. So ground fault protection is required for every system. By code, guys, it's required for 480. You have a 480/277, which we don't. Typically 3-phase, and the amp is 1,000 amp or more. You're required to have a ground fault protection, guys, here, a little sensor right here that senses the ground fault. Look what happens. If you have a ground fault in any phase here, it will sense and it will trip the circuit breaker up on the ground fault fast enough before you burn your building. Okay? So when you guys, Adam, when you work at Machine Cooling and they allow you to touch SKM, and your system is 1,000 amp for 8277, the first thing comes to your mind is, where's my ground fault? Tomorrow, guys, we're not going to talk about ground fault. Guess why? Because our system, not tomorrow, next week when we talk about SKM, because our system is 28120 and 500 amp, so it does not trigger the requirement for the ground fault protection. Special little sensor device that protects you. Here's how it looks like. It only looks, this is the characteristic curve for it. It only looks maximum interrupting time, the curve, the minimum, the maximum when it interrupts for your ground fault. Short circuit panel is not series rated. So then we talked a little bit, guys, about, so that's your ground fault. Panel is not series rated, 100 amp rating, breaker with 50 kVA, branch circuits with 10 kVA. So if this is a series rated panel, if you have a short circuit available, guys, of this amount, your circuit breaker here have to be rated for this. These circuit breaker here, if they are to be rated for this value, then this has to be a series rated. Then this has to be a series rated, right? If it's series rated panel, who cares? Who cares? I always say who cares. Series rated panel are cheaper, guys. say 1/3, almost 1/3 cheaper. That's why we use them. Receptacle panels, Adam, lighting panels are series rated. Mechanical equipment panels, no. Rule of thumb. So what if you don't want it to be series rated? Then all these have to change to 50,000 amp. 50,000 amp, yeah. What's the problem? Cash. Expensive. Bigger equipment too. So that's your series rated. We talked about series rated, a great application. If you have a series rated equipment, typically the manufacturers will series rate the overcurrent protection device, or the engineers like your friend Chad can in the field series rate them. Either way, you have to have, guys, a caution, a table like this. This is engineering series combination system rated, say 1,000 amp or what's not, identify, or 100 amp, identify replacement component required. So meaning you can't just put any circuit breaker there, you have to put the exact circuit breaker. Okay, so that's all. These are all the requirement if it's engineering series rated, or if it's tested series rated, or if an existing application engineers in the field can series rate them too. So these are 3 locations where you can either in any one of them, guys. You have to specify the replacement. Specify the replacement. For your HVAC equipment, Karen, they always tell you, like for example, here's maximum size fuse 40 amp, so you have to have a fuse of 40 amp here and a circuit breaker N of 40. If they told you guys here maximum size fuse 40 amp, you cannot put a non-fuse here. So this is marked with maximum size fuse 40 amp. You either have to put the fuse here or outside, so that will be a violation. If they said a hacker breaker, this is a fuse or a breaker 40 amps, so that hacker will take care of it, and this will be a non-time delay fuse, non-fuse disconnect. So these are your hackers, almost the circuit breakers, all of them are hackers. The rest of these guys are different type of fuses, current limiting fuses and what's not. So feel free to look at all these. When it comes to fuses, Adam, it confuses anyone, guys, unless you use them. There's a lot of types, a lot of sizes, a lot of applications. So circuit breakers, they come in different sizes, rejection. Okay, so neutral, solid, neutral. Here's your circuit breaker, guys. Here's an adjustable. This is a molded case circuit breaker. It looks like this. This is a power circuit breaker or an insulated case circuit breaker. So it looks something similar to that. Overload protection, guys. We went through this one for motors. This is how you size them and the maximum that you can go. Basically, all of them are 120 except 115, except if a service factor 115 or larger, or temperature rises 40, then they allow you 125. We went through that one. When you size overcurrent protection device, guys, for motors, these are all your multipliers. For example, a 3-phase motor, guys, 100 amp will take a 300 amp non-time delay fuse, or 175 amp dual element time delay fuse, or an 800 amp instantaneous, or a 250 amp inverse type circuit breaker. The same motor, depending on what you put on it. So this is a couple of what I like this chart, Karen, when you become a specifier, here's give you the industry class, like L class fuses and the interrupting rating for it, low peak time delay, the type, and all the interrupting rating, the symbol for it, and where it's used, high capacity feeder and what's not. I want you guys to review that. I want to bring RK5. RK5 is dual element circuit breaker here. Current limiting, they have current limitation for that baby. RK1, they're very common, and T. All these are different type of fuses with different voltages and different amps, as well as different interrupting rating and current limiting characteristics. More, if that's not enough for you, Adam, there's more and more of these. The J fuses and what's not, you guys will let you look at these at your own convenience. Look at the different, like I said, different type of fuses. These are fuses to protect circuit breakers too. You can use fuse to protect the circuit breaker. List of prices. I want you to, Derek, look at this. If you have a 100 amp circuit breaker, say 100 amp circuit breaker, interrupting rating 10,000, and 100 amp circuit breaker, interrupting rating 22. Look at the price difference, $189 versus $315. The same circuit breaker, different interrupting rating. Do you guys see why they use series rated equipment? Cheaper. So if you keep going higher, look at this, the same circuit breaker for 100 amp, if from 189 all the way to 100, $8,000. It went from $189 into almost $8,500. Same circuit breaker based on what? The interrupting rating, 100 all the way to 10. So that's major component. Okay, so that's all what I do. I know this is this topic is a little bit tough. Engineering topic that will take you to the next level. Any comments, guys? Any questions about this? This lecture and next lecture, guys, will also be related, and the lecture after, they will be related to a short circuit, and so it's bringing you basically to the short circuit SKM that we're going to be doing next week. So the timing, it can be better. Any comments, guys? Any questions? I know it's a lot of information, Karen. I guarantee you. You guys want to digest as much of it as you can. Next week we'll talk about short circuit calculation, guys. Tomorrow we'll talk about short circuit calculation, and next week we talk about the equipment and conductor short circuit protection. 3 chapters directly related to basically what SKM can do, which is short circuit, arc flash analysis, voltage drop, and what's not. Any comments, Brian, my friend? You made it. That's good. Any comments, my friends? Any questions? I cannot emphasize, I need today or by far Monday, guys, I need to walk through every single thing, Revit, that you have done. We will start printing Monday. You know the presentation, not next week, the week after. So the time is ticking, so keep plugging. Please ask me, guys. There's tons and tons of information, tons and tons of information that you need to put. If you do the assignment day by day, it's easy. If you allow them until the end, it's a lot of information. It's a lot of information. So cool. That's all I have. I don't want to go over the second chapter, guys. I'll wait until tomorrow. Tomorrow I'm going to go, like I said, over short circuit calculation, and then we do have a speaker, guys. Also, just to remind you, so you plan accordingly. Comes at 9 o'clock, so I'll make sure I finish like in 45 minutes before he comes. He'll talk about generators. Gary Buggs will be here to talk about generators. Any comments, any questions? Please, I can't emphasize the word please enough, guys. Ask me about the schedules. Your schedule should be done by Friday and printed. All your schedules should be done and printed by Friday. Otherwise, you're behind. We still have next week and the week after. But keep plugging. So thank you.